Okay, so in this lesson we're going to be using word problems, and typically the steps to solve a word problem would be to identify the variables, translate those words to algebra expressions or equations, set up the equation, then solve. Now, in particular, we're going to have a number of different types of problems. One type is the fixed cost plus a per minute or per hour or per day charge. Cell phones used to operate like this before unlimited plans. And so what you can do with a cell phone is there was a $30, the way this particular plan worked, there's basically a $30 plan per month. You pay that no matter what. That's kind of your fixed cost. And so let's start with that. We've got $30 plus a per whatever charge. In this sense, it's 5 cents a minute. And we want to define our variables. And so we could use something like X if we wanted to, but it's per minute. You know, I might be tempted to use M. So I'm going to say M is, first you might want to say number of minutes. However, that's not quite specific enough because this is every minute over the allotted 1,000 minutes. So the number of minutes over your plan, or overage minutes, you might want to call those. So if M is the number of minutes, I'll say 5 cents a minute. Make sure to convert, this is dollars, $30, so 5 cents would be 0.05 times M. And that's equal to our cost. Well, our cost in this case is $43.50, so that should equal $43.50. We'll go ahead and solve that. And you get $13.50 equals 0.05 M. When you divide by 0.05, so let's see, 1350, using my calculator here, divided by 0.05 is 270. So 270 equals M. Now, is that the answer to our question? You always have to look back and think, what are they asking for? How many minutes did you talk on your cell phone this last month? Well, if I only talked 270 minutes, I would only be charged $30. It's only when I talk over 1,000 minutes I get charged extra. So in this problem, it's going to be 1,270 minutes would be the answer to the question. Now let's move on to the next one. You might face simple interest problems. And so if you don't know what these words mean, I is for interest. The bank actually gives you interest when you invest money in the bank. Principal is how much you invest. If you invested $1,000, that would be your principal amount. Rate is the percentage rate as a decimal. So make sure you convert those to decimals. And then T is time. And we have a choice here. We can do this either, well, let's do it in years. Just makes more sense. That's what they're talking about here. Percentage rates are usually given in years. So Stacy has $5,000 to invest. She invests part of the money at 3% and the rest of the money at 4.5%. So she has two different investments. If Stacy's total interest after 1 year is $195, how much did she invest each amount? So big picture, I like to think big picture first. We have the amount she earned from the first investment. We'll call that 4.5% investment. Plus the amount she earned from the 3% investment. That's going to equal your total interest that you earned. So let's call that interest total. Now we have a formula for interest, so it's PRT here. So for this 4.5%, let's plug in the formula. We have the amount we invested. Well, I don't know how much I invested. I'm just going to call X and say that's the amount invested in the 4.5% investment. We'll just call it that. It doesn't have a fancy name. So P would be X times R is 0.045. I have to convert that to a decimal times T, which is 1. Plus the second investment here, I don't know how much I invested. Well, I know something. I know that between the two of them, they invest 5,000. So if this part invested X, X plus whatever here would equal 5,000. Well, the way to say that is to say the math way, and some of you have done word problems before, and this looks familiar. 5,000 minus X. It's basically the whole minus the part has got to be this other part. Times the rate of 0.03 times the time of 1. All equals the total interest, which was 195.75. Now it's just a matter of solving this problem. So we're going to multiply some of this, 0.045x plus, let's see, 5,000 times 0.03 is 150 minus 0.03x equals 195.75. When we combine like terms here, that subtracts there, I get 0.015x. Subtract 150, I get equals 45.75. I'm going to divide out the 45.75 divided by 0.015. I get 3,000x equals 3,050. Now remember, x represented in dollars the amount invested at 4.5%. Well, how much did I invest at 3%? And so we know the two of them together is going to equal 5,000, so this one would be 1,950. And you've got it. Mixture problems are always fun. I like to draw pictures. Say I'm mixing lima beans with corn to make some vegetable medley of wonderfulness here. So I've got a can or a big vat of lima beans plus a can or a big vat of corn. And I add those together to get my mixture of lima beans and corn. If you ever been to the mall, nut companies do this. They have different kinds of nuts they'll put together into mixtures sometimes. So the cost was 90 cents per pound, 0.90 cents per pound. And the cost of this one was 50 cents per pound, 0.50 cents per pound. And this cost was 0.65 cents per pound. The corn was 16 pounds. Well, how much were the lima beans did we have? Well, it doesn't tell us how many pounds of lima beans. So let's call something like X would be the number of pounds of lima beans. So we'll call that X. Well, the key to this problem is understanding how much mixture you have. Well, you have X pounds of this, 16 pounds of this, so you have X plus 16 pounds. That's just a matter of thinking, okay, let's set up an equation. We almost have it here. This would be 0.9 times X plus 0.5 times 16 equals, I guess I drew that a little too quick here, equals 0.65 times X plus 16. So now it's just a matter of solving that equation. So again, it's 0.9x plus 8 equals 0.65x plus 16 times 0.65 is equal to 10.4. Let me go ahead and subtract that. I get 0.25x. Subtract 8 equals 2.4. If I do 2.4 divided points inside. Let's see, make that number bigger. It does. X is equal to 9.6. Let's look back at what the question is asking for. How many pounds of lima beans that cost 9 must be mixed? Well, 9.6 is the number amount of lima beans. So 9.6 pounds would be the answer there. And finally, one of the most common ones would be this distance, rate, time. You've maybe heard that formula before, possibly even in science class. But it's really common. If you get this idea, so Bill left his house at 2, rode down Main Street at 12 miles per hour. Mary got to his house late. Bill had not waited for Mary. So Mary had to go extra fast and catch up to Bill. And finally does, because she's riding a lot faster than Bill is. So let's talk about Bill's distance equals rate times time. So the distance of Bill equals rate. He was at a rate of 12 miles per hour. The units are really important here. So let's keep this in miles per hour because that's just going to be nice and easy to use here. The time would be t. As long as you understand that t is measured, let's define t as measured time in hours. It's very important that we keep the keep it all consistent here. If this is measured in hours, we're going to do this one in hours. So that's going to come into play in a minute here. Distance that Mary went would be 16 times, and here's the key. Does Mary have 10 less minutes or 10 more minutes? She took less time. She's going faster, so I would say that would be t minus 10. Well, what do we know about these two things here? The distance that Bill went, distance that Mary went. Well, they're really the same. Just one went faster, but they caught up to each other. They all both started at the same starting spot. They're ending together, so I think these two can be set together. 12t equals 16t, and I'm just going to go ahead and distribute that. 16t minus 160. Combine those like terms. 4t equals 160. Divide by 4t equals 40. So, I forgot something, I think, here. You know what I did here? I forgot. We were really working in hours, and I was thinking we were working in minutes. And so that's really 40 minutes. But I really would probably rather do this problem as, let's change that to maybe 1/6 of an hour. I think that would be a better way to do it. So if I solve that problem, I'd have 12t equals 16t minus 16/6, or in other words, 8/3. And then solve, you get 4t equals positive 8/3. Divide by 4, divide by 4. You get t equals 8/3 times 1/4, which those cancel, and you get 2/3. So we do get the same answer pretty much. It's just written a little different form. This is 2/3 of an hour. This is 40 minutes. Now, one last thing. Let's always look back at what's the question asking for. What time did Mary catch up with Bill? Well, what is t? T is the time in hours. It took 2/3 of an hour from the original starting point of 2 p.m. So 2:40, they caught up with each other. So what time? It would be 2:40. 2:40 p.m. And that's how you do at least that type of distance equals rate times time problem. Go ahead and start on your homework and get as many of those as you can.